Hello students, welcome to my YouTube channel. In this video lecture, we are going to continue solving next question from revision questions chapter from Oxford General Navigation book. So let's begin with today's question number 1, question 71. The circumference of the earth is approximately how much? So you must remember this value. The circumference of the earth is equal to 21,600 nautical miles or 40,000 kilometer. Okay, so it's given in chapter number 2. Remember this fact. So it is option delta. Scoring. Next, the angle between the plane of the equator and the plane of the ecliptic is how much? So it is equal to 23.5 degree. Okay, so in time 1 chapter, the angle between the equatorial plane and the ecliptic plane. Eclipse is nothing but the orbit in which the earth rotates or revolves around the sun. Okay, so the angle between them is 23.5 degree. Okay, next. Position A is at 70 degrees south and 30 west. Position B is 70 south, 30, 60 east. What is the great circle track of B from A? Of B from A means you are going from A to B. Okay, measured at A. So let's draw A and B. Both are at same latitudes. 30 west and 60 east. Okay. Now, when both locations are at same latitude, the directions will be Ramline directions will be east west. Okay. So if you want to go from A to B by following this Ramline track A to B will be 090. You're going from western hemisphere to eastern hemisphere. This is your north data. So A to B is 090. Ramline B to A will be reciprocal 270. 270. Okay. We have to find great circle A to B. That means we have to find this great circle. Okay. To find great circle A to B, we must first find a convergency angle. So convergency is D long into sine lat. So difference between these two longitude is 60 east plus 30 west, 90 degree into sine 70. So 90 into sine 70 is equal to 84.5 degree. So let's consider 84. Convergency angle will be convergency half, which is 84 by 2, which is equal to 42 degrees. So convergency angle is 42 degree. Now great circle A to B will be Ramline A to B, which is this much, plus the convergency angle, plus the convergency angle. This addition of both, plus the convergency angle. So Ramline A to B will be equal to 090. Convergency angle is 42. So that is equal to 132. Okay, so the correct answer is 132. Option A. Option number next 74. The value of variation on the chart changes with time. This is due to what? Movement of magnetic poles causing an increase, no, right, wrong. Increase in magnetic field causing an increase, wrong. Reduction in deviation causing a decrease, wrong. So option D is the correct answer. Okay. Movement of the magnetic poles which can cause either increase or decrease. Next, question 75. Isogonal lines converge as follows. So isogonal lines are lines of equal magnetic variation. So they converge at north pole, at north and south magnetic and true poles, north and south magnetic poles, at magnetic equator. So the correct option is option Bravo. Isogonal lines converge at north and south magnetic poles as well as north and south geographic poles. Remember. Next, question 76. Position A is there, position B is there. The great circle A to B is 100. What is run line from A to B? Very simple. So let's draw this. A is here, B is here. So A is 55 north, 30 west. B is 54 north, 20 west. This is your great circle, this is your run line. Now it's given in the question that great circle A to B is 100. 100. Okay. We have to find run line A to B. Now run line A to B is this much, this big angle, right? It is made of two angles. Great circle A to B plus convergency angle. So it is made up of this great circle angle and then this convergency angle, two parts. So I'm writing it here. Run line A to B is great circle A to B plus convergency angle. Now we have great circle A to B. We do not have convergency angle. So let's find that out. So convergency equals to d log in degrees into sine latitude. D log, difference between 30 west and 20 west is 10 degree. Latitude is 54.5. So 10 into sine 54.5 is 8 degree. Convergency angle is 4 degree, half of convergency. So 100 plus 4 is 104 degree. So rub line A to B is 104 degree. Option A is the correct option. Next. Aircraft departs at 4 degree north 170 west. It flies 240 miles south, then east, then north, and then again west. What is its final position? So it's similar to questions that we have already solved in this series and also other questions from RK Bali Oxford that I've already solved and uploaded on my YouTube. So do watch those lectures also if you haven't watched them. Now 4 north, 170 west is your initial location. You travel south 240 miles. Okay, now when you fly along a fixed meridian, north or south, you are actually flying a great circle track. So this translates into great circle distance. D lat into 60. So 240 equals to difference in latitudes into 60. Difference in latitude equals to 240 by 60 which is equal to 4 degree. Now, when you are traveling south, that is when you are in the northern hemisphere and you travel south, the latitudes decrease in value. So the new latitude will be 4 degree north minus 4, the difference between the two latitude. So the new latitude will be 0 degree north south equator. Longitude will remain the same, 170 west. Now from here we are traveling easterly direction, 40 nautical miles east. So the location will be the same latitude, 0 degree north south equator. Longitude will change. The distance is 240. Okay. So this becomes your Rumline formula. Rumline distance d long in minutes into cos lat. So 240 equals to d long in minutes into cos 0. So d log in minutes will be equal to 240. Cos 0 is 1. Now 240 minutes is nothing but 4 degree. Okay. So new longitude will be what? It will be initial longitude plus 4 degree or minus 4 degree. So we will look at another diagram of the earth and we will see whether to add or subtract. I'll show you that. This is your North Pole. For longitudes, draw this diagram. Prime meridian, 180, east-west anti-meridian, 90 east, 90 west. Initial longitude is 170 west. Now easterly directions are always anti-clockwise directions. Okay, easterly directions are anti-clockwise directions. So when you begin from 170 west and you travel easterly, you will be traveling anti-clockwise. So the new longitude will be somewhere to the east of 170 west longitude, meaning the new longitude will be less than 170 degree west longitude. Okay, so new longitude will be equal to initial longitude minus d long. So initial longitude is 170 west, d long is 4 degree. So 170 west minus 4 is equal to 166 degrees. Okay, so 166 degree west is your answer. Next, from this location you travel north. The new latitude we have to find out. The longitude is going to remain the same, 166 west. Now latitude. You have traveled north for a distance of 240 miles. Great circle distance again will be d lat into 60. So d lat equals to 240 by 60, which is 4 degree. Now when you travel in the northerly direction from equator, the latitudes will increase. So new latitude will be 4 degree north. Now from here you travel westerly direction. Okay, for a distance of 240 nautical miles. Another 240 nautical miles. Now your final location can be to the east of this location or to the west of that location. Okay, so we'll find out whether it's to the east or west. For that we will have to use Rumline formula. So again, Rumline distance is d long in minutes into cos lat. So 240 divided by cos 4 is equal to your d long in minutes. That amounts to cos 4 is 0.99. So 240 divided by cos 4 is 240 minutes, or divided by 60, 4 degrees. So new longitude will be 166 initial plus 4 or minus 4. Now see, I'll erase this. Okay, so your initial longitude in this case is 166 west. When you travel westerly direction, you fly and we fly clockwise direction. So new location will be somewhere here to the west of 166 west longitude, meaning this longitude, new longitude will be more than 166. So you will have to add. So new longitude will be equal to initial longitude plus d long. So 166 west plus d long is 4 degree. So 170 west. So new longitude is 170 west. Okay, so 170 west means at the same location. We have ended up at same location, right? So the correct answer will be 4 degree north, 170 west, 170. So the correct option will be option C, 170 degree, 35.36 minutes west. Now why is that? It cannot be 170 west exactly because on the earth longitudes are converging, right? Let's say these are the two longitudes. At equator, these two longitude will be maximum apart. Okay, the distance between them will be maximum. At 4 degree north, the distance between them will be less than this distance. Okay, so over here, when you travel at equator, this is 240 nautical miles. At 4 degree north, the 240 nautical miles will not be equal to this. So 240 nautical mile will go beyond this. Okay, so the final longitude should be beyond 170 west. Okay, it cannot be 170, it can be 171, 172. Now here we have gotten answer uh, 4 degrees, but it should be more than 4 degrees by some value. So it should be 170 degree 35.9 minutes west. Okay. So even if you're getting 170 west accurately, you should know due to convergency of meridians, 240 nautical miles at equator will not be equal to the same 240 nautical miles at 4 degree north latitude. It will be beyond that. So beyond that, there are only two options: 170 degree 35.9 minutes west, 170 degree 1.8 minutes west. It's safer to go with option C. Okay. Next, question 78. At 10 hours, aircraft is on 310 radial from VOR DME at 40-mile range. At 10:15, it is at at a radial of 40 nautical miles and the same distance 40 miles. What is aircraft's track and ground speed? Important sum. This is your VOR station. This is the northerly datum. This is radial 310. This is radial 040. Okay. So at 10 o'clock, aircraft is at 40 nautical miles. From this VOR station. 10:15, it is on radial 040. Distance is same 40. Means it is traveling from this location to the next location like this. Now we have to find track. This what is this track? From this to this location. Now we know that this is radial 310. Aircraft is situated position of aircraft radial 310. Okay. Now radial 310 is nothing but QDR, magnetic bearing away from the station. Therefore, QDM will be equal to 130 magnetic bearing to the station. So this is QDM is 130. To the station the track is 130. We have to find this track. That we will come to know when we know this angle. Now this angle is how much? This angle will be 50 degrees. It will be equal to 50 degree. How? We know this is 360. This is 360, 350, 340, 330, so on and so forth up to 310. So the angle between 310 and 360 will be 50 degree. Okay, the angle will be 50 degrees. This angle will be this angle will be 50 degree. Similarly, this angle will be 40 degrees. Okay, 50 degrees and 40 degrees. Next. So that means the total angle is 90 degrees. Total angle is okay. So I'll draw this. We have a triangle ABC. The angle at A is 50 plus 40, 90. AB is 40 nautical miles and AC is also 40 nautical miles. So two sides of a triangle are equal. That means this becomes your isosceles triangle. If two sides are equal, the angle must also be equal. Okay, that means angle B is equal to angle C. Now the sum of all the angles of a triangle is 180 degree. So 180 equals to this 90 plus C plus B. We know that angle B equals to angle C. So instead of writing angle C, I will write again angle B. So 180 equals to 90 plus 2 of angle B. So 2 angle B equals to 180 divided by 90, which is 180 minus 90 correction, which is 90. Therefore, angle B will be 90 by 2, 45. So this is 45. This is also 45. Okay. So this is 45 degree. This is also 45. Now we can find out track of aircraft. This track of aircraft will be equal to 130 track minus 45 because this track is to the left hand side of this radial inbound, right? Therefore minus, left hand sides are minus. So 130 minus 45 is 085. So the track of aircraft is 085. So eliminate option A and Charlie. B and D is your possible options. Next we have to find what? Ground speed. Now ground speed. Speed is nothing but distance upon time. We know the time. 10 o'clock, 10:15. So time is 15 minutes. Let's find distance. Distance BC we have to find. We know that this is your right angle. So the opposite side will be hypotenuse. So BC square will be AB square plus AC square. So 40 square plus 40 square. So BC square will be 1600 plus 1600, which is equal to 3200. So BC will be equal to square root of 3300, 200, that is equal to 56 nautical miles. So speed will be 56 divided by 15, that is 224 knots. 224 knots. So this becomes the correct answer, option bravo. Next, question number 79. Okay, so we will do the next questions in the next video lecture. I hope you have understood all these questions I have done in this lecture. This question is little unique, so you must practice this question multiple times, and very interesting also. It checks all your basic fundamentals, understanding, and everything else. So do this question, very important for your exam. Subscribe to this channel. Don't forget to share this video with all your friends and like this video lecture. Don't miss my next video lecture. I'll see you there. All the best.